February 1943, deep in a Berlin laboratory, a single screwdriver turned, and history shifted. What German engineers found inside a captured American radio wasn't just a machine, it was a weapon made of wires and sound, a glimpse of the future that would decide the fate of nations. This is the story of the radio that changed the war. February 16, 1943, the screwdriver trembled slightly in Oberingenieur Klaus Hermann's hand as he loosened the final screw on the sealed metal casing of the captured American radio set. The laboratory was silent, except for the low hum of the overhead lights. Around him, 5 of Germany's best communications engineers leaned closer, their faces drawn with concentration and anticipation. The device before them had been seized from American troops during the brutal fighting at Kasserine Pass, the first major clash between US and German forces in North Africa. For months, reports from the front had alarmed the German High Command. Allied radio coordination seemed to have improved dramatically. Artillery strikes landed with uncanny precision. Air support arrived almost instantly. Field units reacted with speed that defied explanation. Something new was allowing the enemy to communicate faster, clearer, and farther than ever before. Now, for the first time, the proof of that mystery sat before them on the metal table. Klaus turned the final screw and carefully lifted the panel away. Inside, beneath a mesh of shielding and coiled wires, was a compact network of circuits and vacuum tubes arranged with unfamiliar precision. "This," he murmured, "isn't like anything we've built." The others nodded silently. They were veterans of Germany's most advanced radio programs, experts in shortwave, longwave, and ultra-high-frequency design. Yet what lay before them was unlike any German model. The layout was smaller, denser, and far more refined. Every joint was cleanly soldered, every tube perfectly aligned. Outside, snow drifted through the grey Berlin sky. Inside the lab, the air thickened with curiosity and unease. The captured set was an SCR-300, the newest American field radio. Known among U.S. troops as a walkie-talkie, it was one of the world's first truly portable FM backpack transceivers. To the German engineers, it represented something close to a technological revolution. For years, German field units had relied on AM, amplitude modulation radios, robust but noisy, easily disrupted by static and weather, and vulnerable to enemy interception. But this machine operated on frequency modulation, or FM. It produced a cleaner signal, largely immune to background interference, and offered voice clarity even through gunfire, smoke, and terrain. The difference was staggering. Klaus and his team dismantled the device piece by piece, documenting each component as if performing an autopsy on the future. The power supply, the crystal-controlled oscillator, the miniature transformers, all told a story of precision engineering. Every part seemed optimized for durability and simplicity in the field. "This transmitter-receiver integration," said Dr. Otto Wehrer, the senior engineer, adjusting his spectacles as he studied the circuit board. "It's elegant. Whoever designed this understood not only electronics, but the chaos of battle." Klaus nodded, scribbling notes furiously. "If this design becomes standard," Vera added quietly, "it could change everything on the battlefield." They all understood what that meant. Germany's Wehrmacht had built its early success on rapid coordinated movement, blitzkrieg, lightning war. But that required constant communication between tanks, infantry, and aircraft. As the war dragged on, Allied jamming, static, and the limits of AM radio had begun to undermine that coordination. Now staring at this small, compact marvel, they could see the tide of technological superiority shifting. Word of the discovery spread rapidly through Berlin's military and scientific networks. Within days, the captured radio was transferred under heavy guard to the Telefunken research laboratories, the very heart of Germany's wartime communications research. A special project group was formed under the supervision of the Ministry of Armaments, overseen by Albert Speer himself. Their mission: reverse engineer the American radio and develop a German equivalent. Fast, but reverse engineering it was far easier said than done. The Americans had achieved a delicate balance between mobility, reliability, and ruggedness that stretched even Germany's technological limits. The SCR-300 had been designed by Motorola, then known as the Galvin Manufacturing Corporation, in cooperation with the U.S. Signal Corps. It was light enough to be carried on a soldier's back, durable enough to survive dust and snow, and could run for hours on battery power alone. Its FM signal meant that entire companies could stay in contact without the static-laden confusion that plagued AM sets. Inside Telefunken's dim laboratories, Gauss and his colleagues began a relentless routine of experimentation. They worked through the night under blackout curtains, dismantling, measuring, testing, and reassembling components until their hands ached. Every detail mattered. The purity of copper in the coils, the grade of mica in the capacitors, the shape of the antenna, even the insulation on the wiring. Yet every discovery came with frustration. Germany's industrial base was beginning to fracture under the weight of war. Allied bombers were systematically targeting electronics factories. Copper, aluminum, and high-quality vacuum tubes were in critical shortage. Many components found in the American radio simply could not be replicated at scale under German wartime conditions. Still, they persevered. By late 1943, Telefunken unveiled a prototype, the Feldfu, short for Feldfunkgerät or field radio device. It was Germany's answer to the walkie-talkie, technically advanced, beautifully engineered, but fragile and temperamental. In the controlled environment of a laboratory, it worked flawlessly. But on the front lines, in mud, snow, and shock, it often failed. It required delicate tuning and constant calibration, luxuries a field operator didn't have in the middle of battle. The engineers knew it was an imperfect imitation. But it revealed a deeper truth. The future of warfare was changing. For centuries, victory had depended on armies, strategy, and firepower. But now, in the modern age, victory would belong to those who could communicate fastest, coordinate smartest, and control information. As 1944 dawned, Gauss watched from Berlin as the tide of war turned decisively against Germany. Allied radio networks multiplied across Europe. American tank divisions maneuvered with uncanny precision. Paratrooper units coordinated airborne assaults in perfect sync with artillery and airstrikes. What once looked like chaos was now a seamless symphony of command and control, powered by a web of FM radios and secure communication lines. At Telefunken, new directives arrived almost daily, desperate attempts to counter Allied advantages. Engineers were ordered to develop jamming devices to disrupt the very systems they had once admired. Klaus spent long nights testing oscillators and transmitters designed to flood the airwaves with noise. But deep down, he knew the truth. They were fighting an invisible war they had already lost. By 1945, as Allied troops closed in on Berlin, the laboratories of Telefunken lay in ruins. Equipment was destroyed or looted, research papers burned or buried. The once bustling center of innovation fell silent beneath the thunder of artillery. Klaus, exhausted and disillusioned, was captured by advancing Soviet troops that spring. Ironically, it was his knowledge of radio circuitry that spared him from imprisonment. The Soviets, eager to rebuild their own communications infrastructure, sought out German scientists and engineers. Many, including radio specialists from Telefunken, were transported east in Operation Oso-Aviakim, the Soviet counterpart to the American Operation Paperclip, which recruited thousands of German scientists to work in U.S. research programs. Klaus found himself in a cold, makeshift lab outside Moscow, studying radio designs not so different from the one he had once disassembled in Berlin. Across the Atlantic, American researchers examined captured German prototypes, fascinated by their precision. The war's technological race had set off something far larger than any one nation could contain. Within a few years, The innovations born in wartime secrecy, vacuum tubes, compact circuits, frequency modulation, would form the foundation of post-war progress, transistor technology, long-range telecommunications, and ultimately the wireless revolution that would connect the world. For Klaus Hermann, the memory of that winter morning in 1943 never faded. The moment he first opened the American radio and glimpsed the future hidden inside. In that small humming box lay a vision of the new age to come, an age where power would no longer be measured by the size of armies or the range of artillery, but by the speed of communication, the flow of information, and the ingenuity of those who could command the invisible, the walkie-talkie. Once a simple field tool had become something more, a symbol of humanity's relentless drive to connect, to understand, and to outthink itself, even in the darkest days of war. That spark of innovation endured, and from the shattered laboratories of Berlin to the factories of Chicago and the test fields of Moscow, a new truth had emerged. The future belonged to those who could hear and be heard first.